Two and a Half Admins, episode 11. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And we're going to have some free consulting for you a bit later. But first, let's talk about a few news stories. The first one is about web bundles. And Brave, the browser, are complaining about this.
Well, of course they are.
Well, this is another web standard Google is putting forward, which will fit in with our second story as well. I think the idea of let's not make URLs be URLs isn't necessarily a great idea. It sounds like Google's plan here is if you could download the whole web page as a bundle rather than, a HTML file that refers to some CSS files and some JavaScript and so on, that'll be faster. It's like, yeah, sure. But if each website is going to customize the bundle it sends you and you're going to have no control over what's in the bundle or anything, it makes it very hard to have any kind of ad blocking or virus scanning or content filtering or anything like that. And I can see Google's business case for, ad blocking. Well, if they can bundle the ad into the website in such a way that you don't load it separately from a different URL.
Websites are doing that already for exactly the same reason, to get around ad blockers. And, it boils down to then you have to block on different characteristics. You don't just block on the URL. You look for, you might look for the, DOM elements that match that ad, whatever. But at the end of the day, this is not something that required a web standard to get around URL blocking tactics. It just, requires the ad to come from the same website. I think Brave is really trying to make a mountain out of a molehill here. I mean, yes, it means you have to be a little bit more clever in your ad blocking, but you are going to have to do that eventually anyway. It's an arms race, and arms races generally don't stop.
But what about the idea of using various CDNs to load different parts of the website concurrently to make the load time much quicker?
Well, it really depends on what the limitation is. Doing more concurrency made sense when the limitation was the latency, how long it took to open the connection and start downloading. But if you've ever noticed, most websites are a couple of megabytes now. So one long-lived TCP connection is going to do a better job of loading that than loading a bunch of small pieces with all those separate round trips.
If you do any web design or web optimization, one of the first tools that you'll want to use on your page is, waterfall analysis, and you look at where things are coming from. Maybe you get a Y-Slow score or, whatever analysis platform you're using, whether it's Google's or Yahoo's or somebody else's. One of the things it's going to grade you on is, how many different sources you have to load things from. And that's because, in part, the more different resources you have to load, the less reliable and, the more hitchy and glitchy the web page is going to tend to be. You can't really get a whole lot more efficient than reading the whole thing as one single resource and flinging it down the pipe as hard as you can.
That's not always been the case, though, right?
No, that has always been the case.
It's always been the case. It's just normally we didn't have a way to say, instead of loading a separate image for every icon on this website, eventually we came up with this idea of, we'll make one big PNG file of it and then use CSS to just crop out the bit we need for each of the different icons and stuff.
Oh, hang on, Alan. I know where Joe's coming from here. He's thinking about back in the old days when browsers would tend to load each resource sequentially rather than in parallel.
Well, in particular, I think it was Internet Explorer would only make 2 or 3 connections to any one web server. So using multiple host names to spread it out.
Right. But none of that is an issue anymore. The issue then was not that you couldn't, in theory, download one thing faster. It was that you had to download 16 things, and your browser would refuse to do them all at once unless you tricked it into that. But that's no longer an issue, and it would be faster in either case to load everything as a single resource than to load 16 resources, whether they are loaded singly or in parallel.
In the end, the idea of using multiple concurrent connections was to reduce the overhead of the latency of making those connections and waiting, the time to first byte on each one and so on. So yes, one big bundle can be better, but it also starts to change the way everything on the internet works. And the question is, what is the problem it's solving and what are the side effects? Which kind of gets into our second story of just because Google wants it doesn't mean we should do it. And because Google wants it means maybe we need to look at it more carefully and how this affects everybody else.
All right, well, the second story that you teased there is from a blog post about a recent document from the Internet Engineering Task Force called The Internet is for End Users.
Yeah, so this is the Internet Architecture Board published an RFC via the IETF process to try to get people to agree. In particular, the way the IETF works is maybe a little different than a lot of standard organizations. Their motto has been, rough consensus. Most people on the mailing list think this is a good idea, and running code. So if you have something that actually works and most people think that's fine, then that's okay, and that eventually can become an internet standard. Now, because it's a standard doesn't mean anybody has to use it. It also has to, get its own adoption and so on. But they've had kind of this bar that people have tried to reach to get something to be a standard and so on. And it's seemed to work quite well for the development of, TCP and IP and DNS and so on. But, it's also had things like SCTP and IPv6, where sure, we have lots of standards around it, but there's maybe not that much adoption of it. But the point of this RFC is a little different, is trying to provoke the IETF to be a bit more political, where they've traditionally tried very hard to try to avoid the politics and so on, but it turns out that you can't really do that as much as we all wish we could. We've seen with the standardization of things like DNS over HTTPS, or the encrypted client hello proposal as part of the new TLS standard. Does it actually accomplish its goals if China is just like, we're going to block all of those packets that look like that? Not that we should necessarily get bullied by China, but suddenly you're starting to see more and more of these political contexts coming into it in both ways, really, where, we can't have a standard that's not going to be legal anywhere, but at the same time, we can't let laws in some country try to force what the rest of the internet's going to do. And it means that we also have to do things like help governments understand how the internet works so they can make laws that don't become fundamentally incompatible with the way the internet works. Or, like we've seen with all these attempts to have like encryption backdoors and so on. It's like, that's just not how it works. And we have to somehow make them understand that, rather than just be like, well, they're idiots and we can just ignore them.
First, you got to get beyond the it's not a truck, it's a series of tubes stage. Then maybe you can talk about encryption.
Yeah.
But in this post from Mark Nottingham and in the RFC, they do make it clear that really the IETF don't really have that much power. It's really all about the companies that are adopting these standards, and it's really up to them to follow them.
Well, people have to follow the standards if they want things to be compatible, but just because the IETF issues a standard doesn't mean anybody has to use it. And that's true. And, Google can go and do whatever they want, and nobody can really stop them. But if Google wants the things to be compatible with other people's things, then they have to go through the standards process.
And that's where the rough consensus comes from. I mean, the whole point is that all these companies that, were hoping to follow these things, they are all coming to a mutual consensus in the first place. And so there's no direct teeth to this. But on the other hand, if you've had a roundtable of all these companies and everybody came to a broad understanding that, okay, this is how we're going to do things, then one company there says, well, screw that. No, we're not gonna. Well, now they're going to have to worry about the things that they would really like, to have happen in upcoming standards. And everybody else is like, nah, we remember what you did last time.
Yeah. Well, and one of the big distinctions with IETF is that each person is there representing themselves, and ideally on a technical basis. In particular, it means anybody can show up to the IETF and everybody's welcome. It's not something like, some of the other cloud foundations and Linux foundations that are pay to play. All the big companies, you can't join unless you pay us $250,000 at least, or whatever. Like anybody can show up to the IETF and raise real objections about technical things or propose better solutions. And I think it's important that we don't let companies like Google run away with the IETF. I don't suppose that's really what's happening, although sometimes we've seen things like new versions of HTTP that were kind of questionable, or even other internet protocols where it's like, so we have this nice design that came out of academia, but would need work to be something production quality. And so maybe we don't want that. Or we do have something that's good, but Google has something that's almost the same, but different. And, Google's got more weight. So we should just do whatever Google wants.
All right. Well, speaking of Google, Jim, you wrote an article about a Chrome feature that, as you say, put an enormous load on global root DNS servers.
Well, if you consider putting, roughly the same amount of load on the root servers as their actual job every day is enormous, which I do, then yeah. And it's not really Chrome, to be specific. It's Chromium, the open source parent of Chrome, and several other browsers now, including Microsoft's new Edge. Everything really boils down to this decision way back in the day. Hey, how cool would it be if my mom could literally just type recipes in the address bar and have it work and take her to a search engine and show her what she's looking for, rather than having to go to, www.google.com or Bing.com, God help you, or whatever first. So, we have this idea now called the Omnibox, where whatever you type in there, the browser has to figure out, is this an URL? Is this a search term? What do I do with it? It's one of these problems that, it's a little bit more complex than it looks at first blush. Because when you're looking for a single word term, the browser can't really be sure whether you're actually doing a single word search term or whether that's a weird intranet request and you're actually trying to go to a private top level domain, wherever you happen to be. Maybe you're at your job and maybe marketing is a private top level domain that actually takes you to an intranet site. And if the browser hijacks that and takes you to a Google search for marketing, it's keeping you from getting where you need to go.
Yeah. And it stems this other very bad decision that happened, I think it was the late 90s or something, where some ISPs started saying, oh, well, if you search up blah, blah, blah.com and it doesn't exist, we'll take you somewhere and give you something instead of just an error page, and we can stick ads on that.
Yeah.
Or we can hijack Google and show you the Google results, but via our affiliate thing, so we get some of the money out of it. And so we got to the point where you couldn't trust, just because the DNS server says that's not a valid domain, you can't trust that it's actually not a valid domain. You put in something invalid, but the DNS server will say, actually, that's fine. It's this thing over here. And you load it, and it's just this catch-all spam page. And then, it's between those two different things, we end up in this weird situation.
And so the Chromium authors knew both of these things. They knew that sometimes a single word entered into the address bar would be a search term, and sometimes it would be a weird private intranet site. And they also knew that, sometimes network operators would hijack things that showed up, in a DNS search, and they didn't want to show people, local ISPs or networks, goofy typo capture pages. And so they decided, in order to detect that, what they would do is every time the browser starts or the system that the browser is running on changes networks. For example, if you go from one tower to another, from your cellular provider, or if you shift over from Wi-Fi to cellular or Wi-Fi to, Ethernet, what the browser does is it generates 3 different random words from 7 to 15 characters, and it looks those up as though they were domains. And if it gets the same IP address on any 2 of those 3 random things that it made up, it assumes that there's a, DNS hijacking going on here. And so therefore, anytime I get a one-word anything, I'm not going to try to resolve it. I'm just going to treat that immediately as a search term and take it off the search engine. The problem is, for those of you who are listening closely, we're actually having to hit the root DNS servers for the entire world for every one of these little probes to try to figure out if somebody local is doing something shady. Because when you make up these, random words on each one of these laptops and you fire off these 3 queries, they can't be properly resolved at the local DNS server or at its forwarder or at the forwarder above that one, or even for the root, for .com or .net or any of your top level domains. You've got to go all the way to the DNS root, and that's the bank of servers that knows the actual addresses for the top level domains, the com, net, biz, UK, what have you.
And that was the interesting thing, is that, that used to be a fairly limited set. And it wasn't such a big deal. But now, years ago, we introduced .info and .biz, which just became, trash piles of the internet. But then with the new thing where, anybody can buy a new TLD tomorrow, if they're willing to put down the $250K or whatever it is, it means that we can't just assume that because you typed in blah, blah, blah gibberish, that somebody hasn't paid to actually make that work now. And so the problems got even worse.
This can't be sustainable, surely.
It's not sustainable, and it should have been incredibly obvious even when the Chromium devs first designed these probes. some grown up in the room should have said, "Oh Lord, no! You are really abusing a hierarchical caching infrastructure here. You are hammering the absolute top level node, bypassing every layer of cache and doing it on a global scale. This will never do." But somehow there was no grown up in the room who said that, and Chromium, at its very, very earliest beginnings, might have been, just another project, but it's been a major browser, if not the major browser, for, a decade plus now. And for that decade plus, it's been abusing the crap out of the DNS root infrastructure. It's kind of mind-boggling.
Yeah, and that's, like you're saying, that's really the tippy top of the internet infrastructure. Whenever you look up a .com, that's where the search starts, at the dot, at the very end. Now, your local ISP or your whatever caching resolver you have is going to have cached the list of places of delegated name servers at control.com, and it's going to be able to use that and avoid going to the root. That's the idea, is that the root doesn't get all these ridiculous queries all the time. It should only be getting this kind of background level of traffic that then gets cached for a long time. And then suddenly it's just like, let's keep asking it a bunch of random bullshit.
Hey, to put this in perspective, when I wrote about this for ours, we had readers that, well, I say readers, they didn't read the whole article or they'd have known the answer. We had people concerned that, maybe this isn't really a whole lot of load in the grand scheme of things. And on VeriSign's portion of the root DNS clusters alone, this extra load adds up to 60 billion queries a day.
Whoa.
I also, you mentioned in our last story, we talked about the IETF and, how we need to get political or we don't want to get political. I will take this opportunity to get my kind of political and say that everything we've been talking about so far, how there should have been a grown up in the room to say, no, you absolutely cannot abuse the top node of a hierarchical caching infrastructure this way. That right there, my friends, is the difference between a developer and a sysadmin. Understanding that right off the bat without having to be told.
Because like the graph, if you look at it, it's not that 60 billion queries is too much. It's that the Chrome nonsense is now more than 50% of all of the queries that the root DNS servers are answering. So your silly little make sure the ISP isn't lying to me check is now more than all of the traffic on the internet. You have to really think about the scale of that.
I believe I've already used the word mind-boggling.
All right, well, let's move on then and do some free consulting. If you want to send your questions in for Jim and Alan, you can do so via email, show@2.5admins.com. And if you want to support creation of these episodes, you can do so on Patreon. All the details for that are at 2.5admins.com. And thank you everyone who has been supporting us. It's very much appreciated. And remember, for $5 or more on Patreon, you can get an advert-free RSS feed. So do check that out. So we've got a couple of questions about monitoring. The first one is from Anestis. I think that's how you say that. In episode 1, Jim mentioned that you don't really have a backup unless you're monitoring it, which got me thinking. For reference, I'm a hobbyist sysadmin, and I've had a home NAS for many years now. Last year, I built a second offsite copy for backup. Both ends have regular automatic snapshots. Recently, one of the drives in the backup NAS started failing silently, and I only noticed when a manual scrub that I do occasionally showed terabytes of corrupted data. Thankfully, my ButterFS RAID had redundancy, so nothing was lost. But it got me wondering, what's the best way to be automatically notified of errors like that in the future? Ideally, something that doesn't require setting up email notifications would be preferred. And the other one is from Andre. He asks, what about monitoring at home? I'm interested in Linux, but Windows and pfSense are also available. Would you still suggest Nagios or maybe CheckMK? It's about, for instance, monitoring the backup jobs, possible hardware errors, etc. It's not about nice pictures with Grafana.
All right. So, tackling these a little bit, one thing at a time. The first listener said preferably something without email notification, and I just want to jump on that with both feet. If you're monitoring with email notifications, you are absolutely doing it wrong. Take it from somebody who has been managing mail servers for more than 20 years now. Email delivery is not reliable enough for notification delivery, and the big problem is that, when things are going well, you don't expect to get an email. When mail delivery is broken, you don't get an email. So what typically happens is, something goes south in, your entire monitoring and email delivery setup, and the monitoring server becomes no longer able to successfully deliver mail to you, whether it's an SMTP configuration or reverse DNS problem, a spam filtering problem, you name it, you stop getting them. And you just think everything's fine because nothing's emailing you to tell you this is broken. Then you find out the hard way that something is really broken because you go to, visit your NAS and there's nothing there. And you discover that mail delivery hasn't been working for the last 6 months and you've just been happy.
Yes. Or you get lots and lots and lots of email and you wish you didn't. That's the other thing with anything that has notifications, whether email or not, is getting it tuned to the right level where you don't get notification fatigue to the point where you're like just ignoring them. I can definitely vouch for having a Nagios tab in my email that's got 6,000 emails I've never looked at.
So the crucial thing here is that, you need to know when you're not monitoring also needs to be, a failure mode that gets your attention. Now, one of the reasons that I like Nagios is because on my own preferred mobile platform, Android, there are several free apps for monitoring Nagios servers. The one I use is called ANAG. And if ANAG can't get to your Nagios server and get an intelligible reply, that will also make it vibrate in your pocket so you can pick it up and look at it and see what's going on. So you don't have this issue where you're not getting notifications and you don't realize that and months go by and then everything's broken because not being able to reach the monitoring server is also one of your failure modes. And the important thing here is that why this works is because since it's tied to your phone and in your pocket. Now, if your phone suddenly is no longer able to do things for you, you're going to figure that out real quick because you use that thing all the time. What I'm getting at here is that setting up an entire, Nagios platform and, putting an app on your phone to hit that server and monitor all the things, it may be too much for some hobbyists. And that's okay. But at the end of the day, what you have to do for monitoring things is you have to somehow figure out a way to make it so that you are certainly making those checks on a regular basis. Now, that can mean just looking at a Nagios tab in your browser that's always open if you set up Nagios. It might literally just mean shelling into your box and, running a zpool status and seeing what it says every day or every week. And, maybe you've got that set up as a recurring event on your phone. But one way or the other, you need a way to make sure that that monitoring is happening and you're seeing it on a regular basis, whether it's good or bad. Now, if you have a larger scale of things to monitor, like Alan or I do, that's where, it gets to the point where you have to set up something like Nagios, because Nagios is going to do the donkey work of making all those checks on all of your systems and machines and, collate all that into one organized bundle in one place that something like ANAG on your phone can monitor and then just bother you by vibrating, in your pocket whenever something goes wrong.
But yeah, I think Jim's point is really good. Is what you want is something that's positive and active. You don't want a passive monitoring system where nothing happens unless you get an alert. You want something where you're going and checking and making sure that everything is fine. And so it's not no news is good news. It's that I checked and nothing is broken.
Absolutely. And, that's one of those things, too. Even if you've got everything, really nicely set up and automated and, blah, 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 like what we've been talking about with Nagios and ANAG on your phone, and your phone works because you use your phone all the time. I don't really have this problem because I'm monitoring and managing literally hundreds of systems, and I get enough alerts to be sure on a daily basis that Nagios does work. Thank you very much. But if you've only got 2 or 3 machines, then, you will likely go months at a time without a notification. So part of your routine needs to be, every once in a while, if I haven't heard anything, I need to look. And that can just mean pulling your phone out and opening up the Nagios app and making sure that it's refreshed and it is showing you the status on all your stuff. Or, maybe it means going to that Nagios tab in your browser. Or again, maybe it just means shelling into your box and looking things over. But one way or another, that needs to be part of it, making sure that if you haven't heard anything, you're checking to make sure that no news really is good news.
Yeah, it can be as simple as having something like a dead man timer like they have on submarines, right? It's like somebody's got to go rewind this clock once a week. Otherwise, if it's been a whole week and nobody's rewound it, it's going to start beeping. And if nobody deals with it then it's going to signal everybody this submarine is lost. It could be something like that, or, being a bit meta. In Nagios, you have both active and passive checks. An active check means Nagios calls out and checks that a service is working, whereas passive is Nagios is sitting there listening and the service will come and say, hey, this is what I've been doing for the last 5 minutes. Here's some data. But Nagios has a feature that says, hey, we have this passive thing. I've not heard any passive data from it for 2 hours. Maybe that means something's wrong, and it will raise an alert even though it didn't get an alert from the passive service. And you almost need to do that to Nagios itself. And so you end up with, your classic conundrum of who watches the watcher to make sure that they're still watching.
So moving on to our second listener's question about whether Nagios is what we would recommend for everybody. If you're not a Linux or BSD or Solaris or what have you person, Nagios is probably not going to be the best answer for you. It may also not be the best answer if you've only got a couple of things that you want to monitor. There is definitely a learning curve to getting it set up and doing it right. It's wonderful in that it's very easy to write your own plugins to check exactly the things you want and, do everything the way that you want it to be done. But it may be a little bit too much overhead for some people, particularly hobbyists. And if you're mostly a Windows person in particular, I don't know of any great free as in beer, much less free as in speech options for monitoring over on the Windows side. But by far the most heavily used on that platform by Windows admins, you're going to be looking for SolarWinds, which I believe is pretty inexpensive for hobbyists on a small scale. And you will be using the same platform that your, much bigger brethren and sistren, or however you say that, are using in the enterprise world.
Yeah, and we also had notes here about Isinga it's apparently like this fork of Nagios that's supposed to be cleaned up somewhat. But I, like Jim, have so many custom Nagios plugins. Well, I think part of the point of Isinga is they're supposed to use the same plugin format.
Yeah.
But like, I've written so much code that just writes Nagios configs for me because, like Jim, hundreds of servers and new ones have to add themselves to Nagios as part of the setup. And it's all automated with their Puppet setup and so on. And it needs to all just happen without me thinking about it. And that's all been built, and there's not, I don't have the activation energy to go and do that again.
Exactly. My understanding is, for all intents and purposes, Isinga is Nagios. All your plugins are still supposed to work. All the things you did in Nagios are still supposed to be doable the same way in Isinga. I just, like Alan, I have never had the spoons to verify that for myself. I got Nagios running when Isinga was much newer, and I don't have anything vaguely like sufficient complaints with Nagios to run a thing that says, well, I'm Nagios, but I'm a little bit different and maybe I look prettier. I just don't care.
It seems to me then that it's worth learning Nagios, because even if it's a bit overkill to start with, it's powerful enough that you can just stick with it and learn more about it as your needs grow.
Yeah, like Isinga might be a better starting place. I think the main point is that the core of it is rewritten in more modern programming paradigms, so it does more threading instead of separate processes and less forking or something. But I don't know if that makes a big enough difference to matter. I tried Zabbix years ago. At the time, it was annoying because you had to, it wasn't really designed for the scale I was doing with hundreds of servers, so adding each machine via the web interface was super annoying. But it wasn't just like, here, use this template to generate 100 config files in a directory and it will just read them all and magically servers will appear. Apparently it's gotten better. The reason I liked Zabbix was it had much better graphing and stuff of the data than Nagios Graph that I use now. But the problem was it kept all the raw data in an SQL database, not a time series database like an RRD or something. And so it either had to take up unreasonable amounts of space, or, you only have graphs going back 2 or 3 months and then it would purge the data. Whereas it's really handy to be able to look at the load specs on a server over a longer period of time, or even just being like, is it this busy every Monday going back the last 6 months? Or is it, is there any correlation between this change in the state of the server and history?
All right, well, I think that answers both of those questions then, so we'd better get out of here. Remember, you can send us those questions at show@2.5admins.com. You can find me on Twitter. I'm at Joe Ressington.
I'm at JRSSNet.
And I'm at Alan Jude.
We'll be back in a couple of weeks.